We're going to be looking at solving simultaneous equations or a system of equations using a matrix method. Now, here it is. We have a question that says, if x plus 2y is equal to 9 and 3x minus 6y is equal to 3, and these are what we call systems of equations or simultaneous equations, where you basically have like two equations with x and y's in them. So we could label this one as equation 1 and equation 2. There you go. And the question could ask us to write an expression in the form ax is equal to b. Hence, we're supposed to solve the equation using a matrix method. Now, A is what we're going to call the coefficient matrix. So A is a coefficient matrix, and it has the coefficients of our variables. Let me put it coefficient matrix. And B, not B, but X rather, X is what we're going to call the variable matrix. And you can guess what it has: variables. And the only variables that we're seeing in this setup or this system is X and Y. So X is going to be our variable matrix. And we're going to say that B is going to be our constant matrix. So again, the A represents all the coefficients for all the variables in a matrix form. And X represents the variable matrix, which has all the variables in the system of equations. And the B represents our constant matrix, which are just the numbers at the end of the equation. So let's go. We're going to start off writing AX equal to B. And remember that A is our coefficient matrix. So looking at the setup, I want the coefficient of this X. If you don't see a number in front of it, then we assume the number is 1. So my first element that I'm going to write is 1. Alright, so this is going to be my coefficient matrix, and the first element in it is 1. Let's look here. The 3 is the coefficient on this X. So like how the 1 was on top, I'm going to write the 3 below the 1. So the 3 would come here. Next, I'm just looking at it and picking out the values. 2 is here, so I'm going to put 2 right beside the 1. And there's a negative 6 beside this one, so I'm going to put negative 6 right here. It is important that you notice that all the X's are lined up and all the Y's are lined up. If they're not lined up, then you would have to rearrange them so that they're lined up before you write the coefficient matrix. So let's just check. So I'm seeing 1, 2, 3, minus 6. So when I look, 1, 2, 3, and minus 6, great. So my coefficient matrix is perfect. It's correct. It's working. Now for my variable matrix, X. So the first variable I'm seeing is X. So I'm going to put X right here. The second variable I'm seeing is Y. So I'm going to put Y right here. So this is my variable matrix. And if I was to multiply matrix A by matrix B, I'm going to get this 2 by 2 matrix up here. Look at it. There we go. So I just extract the coefficients to get my coefficient matrix, and then I just extract variables to get my variable matrix. And the constant matrix is just as how it looks, 9 at the top, 3 at the end. So I'm going to put equal 9 at the top, 3 at the end. Easy so far. So we just wrote an expression in the form ax equal b for the system of equations above. So we're finished with that. The next part of it says that we need to solve the equation using the matrix method. So we're going to try that. If you notice, we need to solve for the variables, which is the variable matrix. And notice that the variable matrix is being multiplied by the coefficient matrix. So in this case, I need to remove this multiplied by a from this x. So let's go ahead and use algebra to help us a little bit. So I need to get x on its own. So I need to remove this multiplied by a. Remember, so we need to remove the multiply by a by dividing both sides by a. Now remember, we cannot divide in matrices. So we have to use another method. Remember the hacks? So we can rewrite this divided by a as a inverse multiplied by the numerator, a times x. And if we did that on the left, we can do it on the right as well. Rewrite this divided by a as a inverse multiplied by b. We know that a inverse times a, or this is supposed to be x. So we know that a inverse times a will give us the identity matrix, and we're multiplying that by the matrix x. And that is supposed to give us or be equal to a inverse times b. The identity matrix multiplied by x will give us what that variable matrix is. So to find x, we need the inverse of matrix A and then multiply that by matrix B. So what I would like to do is to step to the side a little bit and work out the inverse of matrix A. So we know that A, matrix A, is equal to 1, 2, 3, minus 6. And from our previous videos, to get A inverse, we need A inverse is going to be equal to 1 over the determinant of A and multiply that by the adjoint of A. For us to calculate the determinant of A, we need to do A times D minus B times C. And for the adjoint, we write, switch these on the leading diagonal. So we're going to have negative 6 in one's position and 1 in negative 6 position. And then for the off diagonal numbers, they stay in their position, but we negate them. Just like that. So I need to work out this determinant. So this is my A value, my B value, C value, and D value. So A was 1, D was minus 6. When I multiply those, I end up with negative 6. And remember, I'm placing all of that under 1. Continuing, I'm supposed to subtract the product of B times C. So B was 2, C was 3. 2 times 3, that's 6. And I'm multiplying that by the adjoint. It's a little bit of work. I mean, it's a lot of work, but it can be done. So 1 over negative 6 minus 6 gives us minus 12. And we're multiplying this by the adjoint. Remember scalar multiplication. So it simply becomes negative 6 over negative 12, because 1 times 6 or 1 times negative 6 is negative 6. And then you have negative 2 times 1 is negative 2, and it's over negative 12. Negative 1 or negative 1 times minus 3, that's minus 3 over minus 12. And then this is going to be 1 times 1 is 1 over minus 12. And then I can just simplify. There we go. Then I can just simplify. Negative divided by negative should give me a positive. And 6 into 6 goes 1. And 6 into 12 goes 2 times. So this is a positive half. Negative divided by negative gives me a positive. So these cancel. 2 into 2 goes 1. 2 into 12 goes 6. So I have 1/6 right here. Here, negative divided by negative gives us a positive. So these cancel. 3 into 3, 1. 3 into 12, 4. So I have a quarter right here. And then this cannot be reduced any further. So I have 1 or negative 1/12. So A inverse works out to be a half, 1/6, 1 over 4, and negative 1/12. So I'm going to take this matrix and place it right here. So the inverse of A is a half, 1/6, a quarter, negative 1/12. That is what the inverse of A is. And I'm multiplying that by my B matrix from before. So notice that I took the A inverse answer from all of here and placed it in my working space here. So A inverse is this, and I need to multiply it by the matrix B. B was 9, 3. So I'm going to put 9, 3 here. 9, 3. And that should give me my X matrix, which was my variable matrix, which was X and Y. X, Y. So notice that I showed all my working, and I'm proud of it because I worked hard to reach this far. So I'm going to keep it up. Now what's left is for us to actually multiply these matrices out to get a single value for X and Y. So here we are. Let's begin to multiply. So the first thing you want to check is that they're compatible or they're conformable. And we have to write down the order. So this is a 2 by 2 matrix. And this is a 2 by 1 matrix. So number of columns in the first matrix should be equal to the number of rows, so it can work. And the result of our multiplication is going to be a 2 by 1 matrix. This will be the result. And this is also a 2 by 1 matrix. That means the answer that we get in the first row, first column is going to be our X value. And the answer that we get in the second row, first column is going to be our Y value. So let's get straight into it. Remember, when we're multiplying matrices, we multiply row by column. So that's our first row. And this is our one and only column that we're going to multiply by. So I'm going to set up my working matrix. So row by column. So first element is a half, and I'm multiplying that by the first element here, which is 9. And for ease, I'm going to rewrite these whole numbers as fractions. Then I'm going to add to that second element in the row, which is 1/6. And I'm going to multiply that by the next element in the column, 3. So I'm finished with this row and I'm finished with this column. Moving on to the next row, this one. and the same first column. So first element in the new row is a quarter. So a quarter multiplied by the first element in the column, which is 9. Now move on to the second element, negative 1 over 12 multiplied by 3. There we go. So my working matrix is complete. Now it's time for me to actually work it out. So remember in fractions, so I can simply just multiply the numerator with the numerator and the denominator with the denominator. So 1 times 9 is 9, and 2 times 1 is 2. I'm going to add to that 1 times 3, 3, and 6 times 1, 6. Finish with the top one, taking my time, working it out. 1 times 9, 9, and 4 times 1, 4, plus negative 1 times 3, negative 3, over 1 times 12 times 1, 12. Great. And the reason why I didn't say negative 12 is because I just applied the negative to the one of the parts of the fraction, right? And it was just easier for me to apply the negative to the one. So now we're going to have to work with fractions. Whew, this can be difficult. Well, what I would want to do is to reduce all the fractions that I possibly can so that the headache don't start. So I know that 3 can go into 3 one time and 3 can go into 6 2 times. So the top part easy. It becomes 9 over 2 plus a half. Once the denominators are the same, like 2 and 2, it's very easy. But once they're different, problem. So let's look at this one now. 3 into 3 goes 1, 3 into 12 goes 4 times. So I can say, okay, it becomes 9 over 4 minus now 1 over 4. Whew. This fraction one is very easy. So I need to solve it now, break it down as much as possible. If I have 9 halves and I add 1 more to it, I'm going to get 10 halves. So that's 10 over 2. If I have 9 quarters and I take away 1 quarter from it, I'm going to get 8 over 4. And I can break this down again to its lowest terms. 2 into 10 goes 5 times, and 4 into 8 goes 2 times. So the matrix X, being X and Y, is going to be equal to A inverse B, which works out to be 5, 2. Just like that. Therefore, X is equal to 5 and Y is equal to 2. It's a little lengthy, but once you know the tricks and you know how to multiply your matrices and you know how to work with your fractions, you'll be perfectly fine. Here's another example. If 2x plus 3y is equal to 7 and minus 1x plus 5y is equal to 3, first write an expression in the form ax is equal to b. Remember, a is our coefficient matrix, x is our variable matrix, and b is our constant matrix. So I'm going to extract all my variables. I'm going to extract all my coefficients. So that is, let me just circle all of them. That is 2, 3, -1, and 5. So these will be the elements that should be in my coefficient matrix A. 2, -1, 3, and 5. Next, I need to extract my variable matrix. which is x. So I have x and y working with. Those are the two variables I'm working with. So my variable matrix will become x and y. And that is supposed to be equal to my constant matrix. I'm going to be extracting those two from the question. It's 7 and 3. So 7 at the top and 3 right here. And that's that. Next, we're being asked to solve the system of equations using a matrix method. Now, in the form ax is equal to b, I need the values of the variable matrix. I need some solutions to those. So I need to solve for x. To do this, I need to divide both sides by a algebraically, but remember now that there's no division in matrices. So I need to rewrite this divided by a as a inverse times our numerator, ax. And if I do that to the left, then we're going to have to do it on the right. So I'm rewriting this divided by a as a inverse multiplied by the numerator, b. With me so far? A inverse times a will give us the identity matrix, I, and we're multiplying that by x. This is going to give us a inverse times b, and anything times the identity matrix I is that anything, in this case x. So x, or variable matrix, is going to be equal to the inverse of a multiplied by b. Hence, we're going to have to find the inverse of a. So I'm going to come to the side. I'm going to take back the a matrix. A was 2, 3, -1, and 5. And I'm going to try to find its inverse. To find its inverse, we use the formula 1 over the determinant of a, and we're multiplying that by the adjoint of a. So writing the formulas kind of guide me so I know what I'm supposed to do. So 1 over the determinant, and the determinant is the product of the leading diagonal, subtract the product of the off diagonals. So this is the a value, the b value, c, and d value. So a times d, 2 times 5 is 10, and I'm subtracting from that -1 times 3, or 3 times -1, which is -3, and I'm going to multiply that by the adjoint. To find the adjoint, remember, you swap the positions of a and d. So a becomes d, so in this case 2 becomes 5, and 5 becomes 2. With the off diagonal elements, I keep them in the same position, but I negate them. So if this was positive, here it becomes negative, and if this was negative, here it becomes positive. So this is the adjoint. So now I need to just simplify everything. A negative and a negative will give me a positive when I multiply them like this. So 10 plus 3. So to find the inverse, I'm going to have 1 over 13 multiplied by the adjoint 5, 1, -3, and 2. Now I need to use scalar multiplication to get a single matrix. So A inverse is going to be 1 over 13 times 5, 1 over 13 times -3, 1 over 13 times 1, and 1 over 13 times 2. To make life easier for me, I'm going to convert all these integers into fractions by putting them over 1. Then now I'm going to work them out. 1 times 5 is 5. 13 times 1 is 13. 1 times 1 is 1. And 13 times 1 is 13. With me so far? Hopefully. So 1 times negative 3 becomes negative 3. And 13 times 1 is 13. 1 times 2 is 2. And 13 times 1 is 13. So A inverse now becomes 5 over 13. 1 over 13. Negative 3 over 13. And 2 over 13. There. So now I am going to take this matrix and substitute it inside here, because we just worked out what A inverse was. So X is going to be equal to 5 over 13, negative 3 over 13, 1 over 13, 2 over 13, multiplied by my B matrix. And my B matrix was 7, 3. So I'm going to put 7, 3 right here. Great. So all that's left for me to do now is multiply these matrices. So here we are. We need to multiply these matrices now. And remember, to multiply matrices, you have to check that they're conformable. So this is a 2 by 2 matrix. A inverse is a 2 by 2. And B is a 2 by 1. They're conformable because the number of rows in matrix A inverse is the same amount of columns in matrix B. And my resulting matrix should be a 2 by 1 matrix. So let's go. When we're multiplying matrices, remember, we multiply row by column. So let's go. This is going to be my working matrix. So row by column, 5 over 13 multiplied by 7 plus, we finish with these first elements, so I move into the second elements now, plus negative 3 over 13 multiplied by 3. Whew, finish one. Let's go to the next one. So it's going to be row by this column. So first element, 1 over 13, and I'm multiplying that by 7 plus the second element, 2 over 13, multiplied by the second element, 3. That was a lot of work. No, because these are fractions and these are integers, I'm going to rewrite all of these whole numbers or integers as fractions by putting them over 1. This should make life easier for me. Then we just multiply like normal. 5 times 7 give us 35. And 13 times 1 give us 13 in the denominator. We're going to add to that 3 times 3, which is 9. And remember, this is a negative 3. I nearly get catch while ago, but I spot my arrow. So that's a negative 9 over 13. Because 13 times 1 is 13. Great. 1 times 7 is 7. 13 times 1 is 13. Plus 2 times 3 is 6 over 13 times 1 is 13. No, I need to just simplify, right? And if I want to be neat, I can just keep these. So this is going to be X and Y. Keep this as well. Keep that as well. And it becomes X at the top, Y right here. So I just need to simplify these fractions. And they're easy to work with because the denominators are the same. So if I have 35/13 and I'm taking away, because of this minus, 9 of them, I'm going to be left with 24/13. I hope you can see. And then here, if I have 7/13 and I'm adding to that 6/13, I'm going to end up with 13/13, which is simplified to just 1. So the value of X would be 24/13 and 1. As simple as that. Therefore, X is going to be 24/13 and Y will become Y, and Y will become just 1. And if you wanted to, you could convert this improper fraction into a mixed number. 13 into 24 goes 1 time. 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. That's 11. 11/13. And then that's it.